Database sharding is a process of segmenting the data into partitions that are spread on multiple database instances. This is essentially to speed up query and scale the system. I want to talk about the following. I want to discuss what is sharding, and then in order to discuss sharding, we have to gloss over the idea of consistent hashing, talk a little bit about it, and then we're going to talk about the difference between horizontal partitioning and sharding, because those two kind of go hand on hand. And I want to just, there's a slight difference, and I want to talk about that. Like, so that's why I have put a single slide to talk about that, right? And then also we're going to talk about, this is my favorite part, we're going to do an example. We're going to code on a Node.js and spin up multiple Postgres shards, and then write and read from those shards, right? And essentially we're going to build a URL shortener kind of thing. And finally, we're going to talk about the pros and cons of database sharding, because guess what? Nothing is perfect. And finally, we're going to summarize the whole thing. So essentially, before we jump into sharding, just the idea of traditionally how we do things is we have one big database with huge tables, right? And you might have some indexes on those tables. You query and then you get results. It's always a centralized one database. Your pain point is one server, and querying becomes slower and slower the more data you have. Because guess what? You're gonna have indexes, and those indexes are gonna grow large, and as your tables grow large, and that kind of slow down your queries, right? And then you need more memory, and you're gonna need more CPU. So it's just data scale, right? It just makes sense. So if I'm gonna make a select URL from this table where URL equal this, let's say this is like a URL shortener website, right? Which is like one huge table. This is the URLs and this is the code. So essentially what you do is like, hey, give me the URL for this code so I can visit that page, right? That's what the URL shortener does, right? And then you query that. It's a huge table. Let's say there's 1 million rows. So that query is gonna get slower and slower the more rows you have, because even with indexes, that still is gonna get slow, right? Because it's just the index gonna grow and grow. So how do we speed things up? So people invented the idea of sharding. Let's split up that table and put it in multiple databases. It sounds very simple, and that's what it is. It's very simple. It's not really rocket science. You partition your table, row-based partition based on certain field, certain column. We call it partition key or shard key, and we throw those rows on multiple tables uniquely, right? So let's say 200K URLs goes here, another 200K goes here, another 200K goes here. But the question is, how do you shard? How do you distribute? Like, I mean, if you have customer table, that's easy, right? You can do like on the zip code, like these are the zip code for the West Coast, this is a zip code for the East Coast. Or if you have a bunch of users, maybe users from 1 to 500 million goes to this database, and from 501 to 1 million goes to this database. That's another kind of sharding, right? And that's kind of easier. But what if your key is a string like this, right? Which database server is this 5FTOJ is on, right? So it's like, how do you know that? So that's where we're gonna talk about consistent hashing. But there is just a function, and you can always find out. It's not really hard, right? You can build your own function to determine how to consistently hash this input to a server. In this case, hey, I got to server 3. So we're going to talk about a little bit that. Right, and then once you find out which server you want to connect to, you connect to only that server, and you send your query to only that server. That sounds simple, right? You do not want to send your query to all databases to get essentially a bunch of messes, right? You want to connect to the right server that you're sure that your database or your input is actually there, right? And how do you find out that? Meet consistent hashing. So let's assume I have 3 shards, and that's the example we're gonna build, by the way, guys, on the example part of it. And these three databases, let's say I have an input, right? Input 1, right? So the idea of consistent hashing is you take in an input or a string or any user provided piece of data that you want to query on, and you want to know which database to query on. Essentially, that hash is going to give you back that instance somehow, right? So let's say hashing of input 1 will give you database 5432. You're going to go here. So every time you submit the input 1 string, it will always goes to this database, right? And if you submit input 2, somehow this goes to 5433, right? And then if you submit input 3, that might go to server 5434, right? Which is listening in port 5434. And that's kind of a consistent hashing. So as long as you give me always the same string, I'm going to make sure, right, to always consistently hash that to the same server, to the same node, essentially. Okay, and you might get another, like, as again, if you submit input 2 again, you can always get the same output, right? All right, so you might just like, how does actually this work? So one implementation would be just, hey, make this input into some sort of a number, right? I don't know how you do this. Sum all these character ASCII codes, convert it into a binary, and then shove it back to a decimal, and then do a modulo, right, which is the remainder of 3, because I have 3 nodes, and then the input is like, I don't know, if it happened to be 10, right? Let's say you got 10 modulo 3 is, all right, divided by 3, that's 3, and then 9, and it's like the remainder of 1, right? So 1 is you add back 5432, and that equals to 5433, and that goes to this server. So that's how one implementation. I'm not saying that it is, right? And we're going to use one implementation in Node.js that does consistent hashing, essentially, right? They get an input, give me the port number back so I can connect to my database. And yeah, and that is called a hash ring as well, right? So this is like almost like a ring. And then Cassandra uses this all the time with the shards that they have, right? The consistent hashing ring, essentially. So every time you have an input, I know which database to hit. All right, so let's a little bit talk about how the horizontal partitioning versus sharding. Okay, so horizontal partitioning splits this big table into the same database, but it's another table, or maybe to another schema in the same database, right? So you kind of share the same database, but now the client has to know the other schema that has table, or the other table name. It could be customers underscore west or customers underscore east, right? Something like that. So that's the horizontal partitioning. So you kind of spread your data into the same database, right? Sharding, on the other hand, splits the same table into across multiple servers. So you keep the same name, but the database server or the database instance change, right? That's the difference, right? So as we said, like the horizontal partition actually changes the database name, as we said, or they just put in another schema. Well, sharding, everything is the same, but the server change. So that's like essentially the differences between these two guys, right? Horizontal partition and sharding. Sharding, multiple databases, right? And horizontal partitioning, same database, multiple tables. How about we build something, guys? Here's what we're gonna do. We're gonna spin up with Docker, but essentially what we're gonna build is spin up 3 Postgres instances running on these guys, ports 5432, 5433, and 5434, right? And each of them we're gonna create, when we spin up that Docker instance, we're gonna initialize the database with a table, okay? And that table is our URL table, essentially, that has like this short URL shortener, right? We're gonna have some fields and all that stuff, so we don't have to manually go and spin up that. And we're gonna spin up a PG admin to show you the actual shards and all that. So shard 1, shard 2, shard 3, and then we're gonna write some code in Node.js to actually, with the Express, it's our REST API, to write to the sharded application. Let's like, hey, shorten this URL for me, and we're gonna figure out which database to hit, and then write to that database, and then we're gonna read from the sharded database. How about we just jump into it, guys? All right, guys. So the first thing we need to do is to spin up the Docker instances for the Postgres. But in order to do that, each Docker instances that we're gonna spin up have to create that table, that magic table. So the first thing I'm gonna do is create the SQL script that creates the table, the initial table that we will have our stuff. So let's do that. So let's get a directory here called, like, I don't know, sharding video, whatever. And then let's just swap into this folder. And then we're going to create is, let's just create an init.sql file. That's just a file that will have our create statement and a little bit SQL here. Let's write some SQL, guys. So what I want to do is, like, I want to create a table, URL table. That's what I'm going to call it. And if I still remember SQL, we're going to do the first field is called ID, right? And that's serial. That means just incremental. We don't really care about this field much, right? It's not null, right? And it's also a primary key, right? And then the second field is URL. That's the long URL, and that's text, right? And the third field is a URL underscore ID. And that guy is just a character of 5. I want it to be 5 character exactly, all right? So that's just essentially just the structure, the schema of the table. And then because we want to spin up multiple instances, I want this to get executed every time it spin up a new Docker container, right? So that's the first step. Looks good. The script looks good. There's no errors, hopefully, right? And let's just write this thing. Okay, that's the first step. The kind of second step is we need to write a Docker file because our just random Postgres image won't do. We need to create our own image that essentially executes that script. So how do we do that, right? So let's go ahead and create a Docker file, vim here, and then from the Postgres instance, right, the image, I want to just literally add one line of code. I want to copy the init.sql, just the file we wrote, into a special folder called Docker entry point initdb.d. And what that does is essentially the moment you copy that and you spin up the container, that Docker container, the Postgres image, will say, oh, there's a SQL file here. I'm going to execute it. That's what it does, right? So anything you can write in that SQL file, and it doesn't have to be called init, by the way. Anything that you can call it anything you want, right? And then it's going to execute it. And that's cool. That's what we want, right? So now we're ready. So what we're going to do here is let's build the image, right? And because we have the Docker file, let's build the image from which we're going to spin up the containers. So the next step is we want to build the image from that Docker file because that's a special image. I don't want to run my Postgres from just the vanilla Postgres image. I want to run from this special image. And let's build that image because nobody knows about it, right? So what we do to build that image, like you do go docker build -t, and I'm gonna call it pg shard, right? And that's how you tag it, essentially tag the image, or -t, right? I don't know why it's called -- name, just like the container name, but people like to be confusing, so I don't know. And then once you do that, you do a dot at the end. That's very important because I want to build the current directory. And then when you do that, you and that's done. So my image is called pg shard, right? How about we spin up some container, guys? Let's spin up some containers, right? And then finally, once we spin up the container, I'm going to spin up also my pg admin container to administrator those things, right? And then, so let's spin up docker run -- name, because always a good idea to give it a name. I'm going to call it pg shard1, okay? The first shard, let me do this so you can see it, guys. The first shard, the port is 5432, and then the image is pg shard, remember? And that's it. And how about we detach it because we don't really want, we don't want to occupy the terminal. So do that. And we have one shard, baby. So let's spin up another shard on port 5433. 2. Nice. And 4. Sweet. All right, guys. So just like that, we have 3 instances, database instances. One is running on 5432, one is running on 5433, and 3, 4. And by default, if I connect, I'm going to show you now all these shards, right? I'm going to use pgadmin Docker container. I'm not going to show you how to spin up a pgadmin because I already did it in another video. Go check it out. I'm going to reference it here. But I already have a Docker image called pgadmin, so I'm going to just use that one, right? So it's essentially, it's listening to port 5555. Let's just check it out. pgadmin. That's the one. That's the one. I have it running for a long time now. It's called DPG and it's called pgadmin and it's listening on port 5555. So I'm just going to use that to manage my shards. How about that? Let's just do that. Let's show you that these shards has been executed and then spun up and then have the schema of the table, and those tables have to be empty or obviously, right? All right, guys. So I have pgadmin here. I logged in, and then let's start adding my servers, my database server. So I'm gonna add a server. I'm gonna call it shard1, and the database is, remember, it's Hussein Mac. That's my machine, and it's running on port 5432. And the default users, when you don't specify anything, the properties, the password and username becomes Postgres, and the database also becomes Postgres. So everything in the same thing. All right, so now we have Postgres schema, public tables, URL table. Look at that. That's the table we created, guys. And that's all this stuff we have. All right, let's add the other two, right? Shard2, it's Hussein Mac, and that's 3. Postgres, and let's just add the third one, Shard3, Hussein Mac, and that's port 4, right? Then Postgres, and we have 3 shards, guys, and the same exact thing, same exact schema. That's what we want. So our sharding setup is ready. How about we write some code, guys? All right, guys, so I have Visual Studio Code here. The minimum requirements, you're gonna have Node.js installed and Visual Studio Code, and you can start working on this stuff right there. All right, so I'm gonna go ahead and open a brand new folder. Let's go ahead and create a JavaScript playground. I'm gonna call it Sharding, right? And open. And what I'm gonna do is create a file called index.js, the best file ever. And then let's initialize npm because it's a new project, right? So npm init-y, that means shut up, I know what I'm doing. Just create a package.json. It's called sharding. Sweet. All right, so now remember, guys, we did a tutorial on how to work with Postgres from Node.js using a very beautiful library called PG, right? And we're going to use the exact same library to connect to the databases, essentially, right? And what we're building here is like we're building a web application that have a post and a get, right? Post will create a URL shortener, right? Will shorten a URL, given a URL, and get will, given that URL code, the short URL, will give me the long URL. It's very simple stuff, right? So let's go ahead and obviously we're gonna need express. So we're gonna do require express, spin up that express, beautiful stuff, app.get. I'm gonna do something with this thing, request response. That's the get command, app.post, that's the post command. That's what we will actually write, right? Our beautiful, beautiful URL shortener, okay? And here's what we want. We want the databases, guys. So the database is called const client, right? And let's use this structured assignment. I know sometimes it's confusing, right? This is essentially called the library for the Postgres database called PG, right? You can either do it this way or just do the destructuring assignment, whatever rocks your boat, right? That's exactly the same. All right, and we have the client. What do we do with the client? We need to spin up multiple clients. We have to spin up 3 clients. So here's what we're gonna do. So we're gonna create a clients, right? JSON object, and the JSON object, the key will be the port, because I want to play this trick here, where the key is the port, and the JSON value is the configuration here. So how do we do this? Is essentially 5432. That's the first client. And the value is new client, and then you pass in the beautiful configuration. So what do we do here? We put the host, right? Hossein Mac. Again, guys, I have done through all that stuff. If you want detailed tutorial about the Postgres itself, I'm going to reference that video, but this will be just skimming through these stuff, right? So port, obviously port 5432. And what else? User is Postgres. Password is also Postgres. And database is also Postgres. I'm just lazy, guys. Just use the same exact thing, right? And then that's one client. We need other two clients, right? The client running on port 33 and the client running on 4. How about that, guys? I think we're good here. So that is a bunch of clients, right? Still, we didn't connect them. How do we connect, right? So we need a function called connect here. So let's just, because I'm going to use the async await here. So I'm going to do a function called connect function, if I can spell, connect. And what we're going to do essentially is just literally call this function immediately and then connect those guys, right? So we can do like fancy loop or just the old school way where just like literally 5432 dot connect, right? Just connect those TCP connections, establish those beautiful TCP connections, right? A try catch would be nice here, right? But I'm trying to go through the video real quick. So that's will actually give us the client's connections. Beautiful stuff. What's next, guys? We need, the next thing is, let's start with the writing aspect of it, right? So writing a new row, right? So I'm going to write to the database, okay? So how do we write, right? So posting, let's assume I'm going to get the URL of the query parameter. And we're going to I made a video about the query parameters versus resources. If you're interested in that, go watch that video. I'm going to reference it here. But you're going to do request.queryParameter.url. So just give that URL. And once you get that URL, here's the thing. We need to consistently hash that thing. Hash this to get a port. So how do we do this? This is the consistent hash that we talked about, guys. So let's do that. So there's a library called consistent hash. And I think it's called literally consistent hash. I think it's called that. Right, so it's called consistent dash hash. So that's what it's called, right? And then when you do that, what you essentially want to do is create a hash ring, that the one we just talked about, right? So it's like a hash ring of how many nodes in this case? We have 3 nodes. It's really easy stuff. So I'm going to create a hash ring, HR, equal new consistent hash, right? So we're going to create a hash ring, right? And then we start adding our nodes, right? But we're not going to get IntelliSense, I think. Yeah, that's what I thought. So let's go ahead and just install all that stuff because we have done a lot of stuff and we have never installed any of that stuff, right? Right, so let's go ahead and do npm install express, and we're gonna install pg. We're gonna install consistent dash hash. Let's install that stuff. We have installed all of that stuff, right? We're gonna also need crypto, but we'll use it when we really need it. Okay, so hr dot, there you go. There is the IntelliSense hr dot add. Okay, and what are we adding here? We're adding essentially these puppies, right? We have 3 nodes to be consistently hash, right? And it's so easy to use, guys. So once we add all that stuff, here's the thing, right? For now, I'm going to do a post, right? And if you give me the URL, right, I'm going to hash that URL and then get a result out of it, right? And then based on that result, take the first 5 characters and that becomes essentially my code, right? So let's go ahead and actually do install, might as well just do crypto as well, right? Const crypto equal require crypto. All right, we're going to use crypto to do the hashing, guys, that we talked about. So what we want to do essentially is take that big URL. So the URL could be, I don't know, www.wikipedia.com/sharding, like something like that, right? And I want to take that string and make it into a beautiful hash base 64. So how do we do that, right? So crypto dot, I think called create hash, right? And then you have to specify the functions called SHA-256, because that's what the hash I'm interested in. And you want to update that string of data you have. So generate the hash, and then you want to convert it to base 64, which is called, I think, digest, right? And then called base 64. That's what you do. Sweet. That gives you a beautiful hash, guys. It's just a string of hash, and that hash is a little bit long. So let's go ahead and actually run this thing, guys, so you can see. So let's go ahead and just response.send back. I don't know. Let's just send back the same information. So the hash we got, and so far we don't have any other information, right? That's it. So let's just go ahead and run and make sure everything is running, right? So app, we have the app get. We forgot to listen. Let's go app.listen 8081, right? I want to listen to port 8081. I think it's just a number, so let's just do a number. And then do console.log listening to 8081, right? So let's just go ahead and debug, make sure we don't have any errors. I think we're gonna get an error because we didn't install crypto, right? We didn't install crypto, did we? Right, let's go ahead and install crypto just in case. npm install crypto. Let's run it again. And we're listening to port 81. So we want to do a post request to this puppy, right? Let's see what will happen now. Okay, remember guys, what we're gonna do is give me a URL, and from URL, I'm gonna hash that thing and get a big hash string. I'm gonna take only the 5 characters. Again, guys, this is not the perfect implementation of URL shortener. There are way better guys than me doing an actual design and thought 2-hour, 1-hour video just how to build a proper hash function and to do URL shortener. This is just to give you an idea of sharding, right? All right, so let's go to the browser. All right, guys, so we go to our favorite console, right? I'm gonna use the beautiful fetch API, right? Just do old school way. It's 8081, and I am actually, the URL is https wikipedia.com/sharding, whatever, right? And then yeah, we're doing a method, right? The method is post, and I think that's all what we need, right? Then I'm expecting JSON back. Give me JSON, baby, and console.log. Whoop, we made a request. Immediately we get the breakpoint, we get the sharding, we get the URL, and then hash the stuff, and we get this beautiful string. Look at that. That string, I'm only interested in the first 5 characters, right? We're gonna take that 5 characters and shove it in the database, right, as a URL code or URL ID, whatever we called it. And then that hash will determine where are we gonna hit, which server is gonna hit. I'm gonna talk about that now, right? So if we're gonna do that, return, we're gonna obviously get what we're getting an error for some reason. Access to fetch from origin. Oh, we're not in the wrong origin. Duh. All right, sure. Let's just do localhost 8081. Happier now? Okay. We're in the same location. You happy now? You happy now? I think you're happy. I think you're happy. I think you're happy. All right. Good. 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 All right. So it's just like this is a course thing. We talked about course. Oh my God, we talked about a lot of stuff in this channel, guys. How are you still here? There's so much stuff, right? So there's a lot of tech, right? And just exploring all this stuff, right, you slightly become a better software engineer as you hit these things and start understanding, right? Course, beautiful course stuff. All right, I could have added something on the server that allows other people to access this, but I just don't feel like it. All right, so we get the hash back. This is not where I want to go though. I want the URL code. What is the URL code, guys? The URL code is essentially URL ID equal hash.substring 0 to 5. That's what I'm interested in, the first five characters. Not sure, computer science stuff, is this gonna give me 5 characters or 6, right? The struggle, man. I always struggle with these bits then, right? You'd think 15 years experience in computer science, you still get this wrong, man. Because every implementation get this. Sometimes like the strings get it, oh, start from 1, sometimes from 0. Everyone implements their own stuff, man. Right, so let's just do hash again. What did we get it right? Did we get it right? Yes. Looks like 5 characters to me, right? 0, 1, 2, 3, 4, 5, right? So you would think that this is going to give you 6 characters because 0 to 5 is actually, never mind. All right, so now we get back the URL, guys. Look at that. Give you that. And if I do it again, let's just remove the breakpoint. It's just getting annoying now at this point. Getting annoying. Getting annoying. Remove it. Right? And every time we get that, we're going to get the same key, right? But let's say change the URL to something else and we get a completely different key, right? That's not what we want. We have the key. Now I can write it to the database. We're ready almost. We're almost ready, guys. Almost ready. Let's just throw in the URL, actual URL here. How about that? Okay. Just throwing a URL, sure. And then I'm going to throw in the server because I don't know which server I'm going to connect to. That's the tricky part, right? Right? So how do I know which server to connect to? Very easy. Back to the consistent hashing, right? HR, the hash rank. Remember, we added 3 nodes to the hash rank, right? All we need to do is ask the node, hey, hash rank, I have this input, which is called URL ID. Give me one of the 3 nodes. And it would do its magic. It will do a modulo, whatever the implementation is, and it's going to give you a server. That's the beauty of this thing. Let's do it. So let's see what server do we get. If I do this, let's clean this up, and then do boop. Look at that. We got, for sharding 1, we got server 5432, and with this key, right? That's funny. It actually says key. Oh my God. That's completely a coincidence. Let's say sharding 2, we're still heading in the same server. Sharding 3, we had another server, 5434. So it completely almost random, right? How about random? Random. I want to hit, please give me the server 33. We didn't hit that server yet. .bh, Bahrain. Okay, 5432. Damn it. I want 5433. Can you give me 5433? Hey, random 2. That gives me 5433. Okay, that's what I'm talking about, right? Just as you start running, this will almost balance that stuff in a consistent manner. And every time you do the same exact way, you're gonna hit the same exact server. Okay, we have all the pieces, guys. All the pieces is here. So how about we actually write this stuff to the database, right? Let's write it. How do you write stuff to the database? Very simple. We need to get the client, right? The clients are in this bunch, right? Clients, sub. Guess what? What's the sub here? I want the sub server, right? Because this is the key, right? Because now I have the server, which is a string, which is the port. That will give me back the object. And the object, when I get that thing, I want to query, right? Is that right? Why is it not showing me IntelliSense? I think it's unaware that it's actually an object. Well, I'm pretty sure that should work. So select star, bad idea. Don't ever do a select star in your database unless you know what you're doing, right? So it's called URL underscore table. Right? I like to make things big. That's what she said. Select star from URL underscore table. Yeah, I don't know what SQL always has to be caps lock. All right, it's just something we learned back when I used to do Oracle stuff back in 2005, 4 actually. Yeah, first job. All right, so where we do where what? Why are we selecting? That's nuts. We're inserting. Insert into URL table, right? I'm inserting what? ID is going to be automatically generated, the URL and the URL ID. And then we do values, and then the fancy stuff, 1 and 2, and the 1 is equal URL, and the other one is URL ID. Okay, sounds good, right? This looks like an insert to me, right? And that will insert, but you have to await it, right? And since we're awaiting, that function that we're in better be async, right? That's okay. Then we have to send that push. Are we still recording? Yeah, good. All right, so now we're sending that back, and then we are sure that, hey, we got it, okay? I mean, I can add a try catch and be like a little bit more fancy, but yeah, let's just make sure that we actually made it, right? Otherwise, we're gonna get an error. So, let's do it, guys. Let's do it. Refresh, right? And post. Wow. That's bold. Did that work? How about that? What server is that? 5433. So how do we go? What is 5433? Ah, damn it. I should have just put the right number here. I don't know which one server is 4433. I think that's the one. Okay. Chart2 is 4433. Okay. Public. And we go tables. Do we have a row, guys? Do we have a row? Yes, sorry. What the heck was that? Printing PDF? Why? Jesus. Okay. Chill. Look at that. Beautiful stuff, guys. Wow. Well, how about we do another one? Okay. Another one. DJ Khalid. Right? Damn it, same server? Okay, sure. It's even easier for me. Right. Woo! Look at that. Another one. And that's the key. Right? Let's do, I don't know, google.com. Doesn't have to be Wikipedia. Right? Ali. Refresh. Which server? What did it? Oh, that we had another server. Let's do it. Let's go to that server. 5 short 3. Guys, I'm gonna reference the code below, so you don't have to like pause and do all that stuff, right? Goofy stuff. You just go to the GitHub page. Look at that, guys. So we're consistently hashing the F out of this stuff, man. Consistent, babes. That's what we're talking about. Consistently. All right. How about that? Let's just throwing some URLs. Yeah. How about that? URLs equal. How do I do URLs? Right. Let's just do URLs. Yeah. I less than 100. I plus plus. And then there's like URLs to push. HTTPS google.com/in India, because why not? Let's go there. I search for Q equal test I. All right, I have to do the text. Can you read, guys? Hope you can read this. Okay, I'm gonna zoom in a little bit. All right, sorry about that. All right, so we added like how many URLs? We have a lot of URLs, guys. So many URLs. Oh my God, let's go and let's do it right this time, guys. For each, you didn't on me. I like it when you're down. You believe God is a woman. All right. You. All right. I think that's right. Right? Did I get it right? I really doubt it. But sure, let's do it. Oh, mamacita. Look at that. Look at all that stuff. Okay, so we had like a bunch of servers. We had 5433, 54, all that jazz. All right. Search. Oh my God. Look at all the beautiful stuff, man. All right. We know this stuff is working, guys. We're distributedly consistent. All right. How about that? All right. We did the post. How about we do the get? The get will be easy, right? Let's do the get. You get. Let's get that thing, right? And what do we do? To do a get, essentially, what we are getting from the server is, all right, so I'm going to do it fancier this time, right? So I'm going to use the, like that, ID. I think it's called like that. Is it colon ID, I think? So the URL ID will be like that, right? will be part of the URL. So like if you do like https localhost 8081, and then you do like blah 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 this URL, this will be the URL ID. Get it? Okay, get it? I don't think you get it, guys. I gotta spell out everything with you guys. Sheesh. All right. So const URL ID will be equal request, but I think it's called params dot URL ID, right? And when you do it this way, I think I might be wrong. So we'll check it out. Okay. So URL ID. All right. So we get the URL ID, which is this thing, right? Right. So what do? We need to query, right? First, to do the query, we need to find which database to hit. And to do that, we don't need to hash because we have the hash, right? Arby's, we have the meat. All right, so we do that. Get the URL, get the server. And once you get the server, now we know which server, we know which client. So we essentially do this, right? Easy peasy, Japanese, right? So we don't need this, all right? We just need to query, right? And select star, again, never do this, right? Never, ever, ever do this. URL table, is that what it's called? Is it URL table or table URL? All right, so select star from URL table where URL ID is equal to 1. Thank God. What's his name? This guy who built this library? I think his name is Brian. Brilliant guy, man. Follow him on Twitter, right? Brilliant guy. Okay, so what do we do? The URL ID. I want to give you that. So you don't have to do that nasty single quotes and the blah blah blah. You don't have to do that because you'll be SQL injected. And by the way, we talked about SQL injection because I talk about everything I want to learn in this channel because my goal is to become a better software engineer every day. So anything that I don't know, essentially I make a video about it. I learn it and I make a video about it. So SQL injection, go check it out. Okay, we have that stuff. What about we actually check this stuff out? Okay, so this gives me results, and I think I awaited that thing. The results have a row, so result.rows, I think it's called rows count. Is it greater than 0? Then we just send back the result, I guess. And then if there is no results, what's the status code for something that is not found, guide? 404? Send the status. Okay, let's send status 404. There's 404, right? Because it's not found, right? If it's found, then I'm going to return this thing, right? And what do we do? URL ID. What else? What else? All right, so URL ID. Let's just do the same exact thing so we don't mess up, right? Stay consistent. Consistent hashing, babes. All right, so the URL ID is the same one. I don't really care. I want this guy. And it tells me which server I went to pick that thing up. All right, looks like it's working. All right, let's debug. Do it. Do it. Only valid in async function. Yes, sir, because I forgot to add async here. Thank you. All right. Okay, let's do this. Get. Well, get is easy. Just do this. And now I need something that actually exists, right? This is not found. It's funny. It actually tells you not found, right? Because now it's going to return for me at 404 here because this dasa doesn't exist. Dasa doesn't exist. 404 not found. Okay. So how about we find something that is actually there? Okay. So if I go to any server, right, just pick up any server. What's this? Shard 3? Yeah, the server. If you do this, right, it's not working. Or okay. All right. Might have some bugs, guys. Let's go on. Let's go check what's going on. Hit it. Did I get this right? Yes, I get it. NHCM7, all right? And if I do that, I'm going to get it says in server 5432. And if I query, right, and I get rows count 0. Ooh, row count. There's no rows count. It's row count. Right? Plus, even though I didn't get any rows back, right? So let's see what we did. What are we doing wrong here, guys? All right, guys, I had to pause the video. We found a big, huge bug on one of the implementation of the old library, the consistent hash library. For some reason, when I practiced this video, I didn't hit it, but I hit it during this video while recording this video. And apparently, that hash ring thing, that consistent hash, was not giving me the same value. So it was stupid and useless, right? It's just buggy implementation. So I found another library called hashring, which is a correct implementation finally. It's exactly the same, right? So you're gonna add the same thing, hr, add this. But now, when I do a get, right, with a key, it's the same thing exactly. Right? It gives me the same value every time because that's what I want. I don't want it to give me random values. That defeats the purpose of a consistent hash ring. I don't know what that implementation was about, right? So I checked out and it's like, it wasn't updated for 4 years, so it was a bad idea for me, so I apologize. So the rest of the video will use this hash ring instead of the consistent dash hash, right? Apologize for that, but it's the same implementation, right? It's the same idea. Nothing changed. The latest code will use the hash ring. So now, if I actually, I went and then truncated all the rows on all my shard and repopulated it with a brand new set of IDs, right? So now, I go back to get right here. And if I do, like, let's say I went back here and it's like, okay, shard, what? I'm in shard 3 and I want E4 RJX. So this is what? Shard 3, right? Shard 3, and I did, okay, go ahead and show me that for that ID. I get back shard 3, right? So let's go ahead to actually shard one of the rows in shard 1, okay? And let's check that out. Do we get the values here? So yeah, there's a bunch of values here. Let's pick one of them. And then MC875, if I do that, right? Let's just refresh that thing, right? And if I do, give me that, I'm gonna hit shard 1, 5432. That's exactly what we want, right? Powerful stuff, right? So once we get that, I know which server to go, right? So let's go ahead and complete the query and add all that jazz, right? So let's go ahead. So we get the result back from the query, right? If the result, the row count, I think it's called, greater than 0, then I want to send back, obviously, this result, right, guys? And I want to actually just send the rows back, right? Just go ahead and send it. We can just do, yeah, because we're going to get one row back, right? This implementation, by the way, guys, could have duplicates, right? I didn't account for duplicate, but it's easy to fix, right? I'm not going to fix it here, obviously. This is a sharding video, not a whole URL shortener design course, right? So URL short, so give me the idea. I'm going to get the URL. How do I get the URL? I can do this. Rows sub 0. And let's just do row sub 0. I don't know the actual values there. So, and that's server. Right? And then if you couldn't find it, we said we're gonna do response.send status 404. Okay, that is coolish. Let's do it. And let's just remove that breakpoint so it doesn't get annoying. Oh, look at that. We got it. It's row ID 40 and it's from server this and all that jazz, right? So how about we pick another one? Another one, DJ Khaled. That's the same server, right? That's how about we pick up another server. And that's when I truncated those tables. Let's go shard 2. How about that? Let's pick something from shard 2. So we prove that actually this shit is working, right? Look at that, shard 2, 5433, and we picked that result. So I spread out my databases and now my rows on my tables, and now I'm always getting that stuff back. Powerful stuff, right? So we know how to write, we know how to read, and that's essentially the basics of sharding, right? And what if I do something that doesn't exist? I get not found, right? And if I do that, right, just not found, right? So a very basic implementation of a URL shortener with sharding giving to you guys, right? Hope you enjoy it. It's the code will be in the description below. So it's not that bad, right? It's like for sharding, that's a pretty cool if you think about it, right? Now, guys, adding shards is not something easy. You cannot just add a new shard because you have to really be careful what you're doing, right? You have to be careful with the algorithm, right? So the one I did is like it's fixed with the number of shard, right? So the moment I add a new shard, it's gonna redistribute and everything is gonna go to F, right? So you really need to know what you're doing with this. Sharding and resharding is a different topic. It's one of the disadvantages actually of sharding. So right. So that's it. Let's just jump back into the slides and talk about the pros and cons of sharding. All right, guys. So we talked about sharding a little bit. We did an implementation with sharding, with consistent hashing and all that jazz, right? Pretty coolish stuff, right? How about we talked about the pros and cons of sharding? Is this perfect? Well, let's check it out and see. So what the pros of sharding is you're gonna get scalability, and that's both in data, memory, and even CPU, and any resource that is on your server. Instead of having your server essentially this resources is getting hogged with one machine, you can spread the load on multiple machines, like thus horizontally partition, horizontally scale things, right? Because now essentially your data is essentially spread out, and now the client is aware of which shard is where, and then just like need to know and hit that essentially and just build that up, right? So that's essentially what needs to happen. So you get scalability for free. That's great, right? You also get security, right? And that's that's an interesting one. Let's say you like if you have like certain customers' data, you want this shard of customers to be accessed only by certain people, right? So you can put your VIP customers in one shard and other customers are in other shards, right? And then you can have little bit access control on what shard can be accessed by which clients. So with that, instead of having everything in one table, you kind of spread it out and have kind of access control over which shards. Like, hey, sorry, you cannot access this shard, right? So you can essentially have this level of control of security with pros, with sharding. That's pretty cool stuff, right? And it's optimal because you're going to get a smaller and smaller and smaller index size. And that's cool, right? Because the smaller index you get, the better and the quicker and more efficient queries become, right? Cool stuff. About cons, is there anything bad with this? Well, you saw the code, guys. See how complex our clients get? It's so complicated, right? The clients becomes very complicated because they are aware of this sharding thing and they need to know, it's like, oh, this input is in this shard and this input is in this shard. Well, you can use consistent hashing to hide that, but still the awareness of the shards become really complicated. As you start building a huge application, this becomes really nasty, right? It becomes really nasty to have a complexity into the client itself. Vitess, which I think I'm gonna make a video about. It's a tech from YouTube that allows you to do sharding on the spot, and it's hidden from you. It's a back-end sharding, right? And the client just makes the query and it does the sharding for you, which is pretty cool tech, right? So that's Vitess. We're gonna talk about that. Transactions across shard is a problem. How do I do like two inserts that happen to have two tables, right? And I want them to do it atomically. That's almost impossible because you're essentially doing two database transactions, two separate database atomic transactions. It's almost impossible. It's very hard to do, right? So you can't do transactions very effectively with sharding, right? I mean, if you do it on the same shard, that's yes, you can do that. Rollbacks are very hard. Like, let's say, oh, I want to insert in this table, and then I want to insert in that table, but ooh, something bad happened. Let's roll back everything. Well, what does that mean? You can roll back this transaction, also you'll roll back the other transaction, despite it being one logical transaction, complicating stuff, right? Rollbacks are very hard. Schema changes. Let's say I want to add another field to my URL table. I don't know, date or something. I have to add it in all the shards, right? It's like I make a change in all the shards, and you can just roll this change slowly if you want to, but it's a little bit dangerous, right? If you miss adding one schema in one shard, but you add it to the other shards. Joins, I have no idea how to do joins across databases. Is that even possible, right? It just becomes very hard to do joins, right? That's why you might use horizontal partitioning instead of sharding. So your stuff, that's one benefit of HR, horizontal partitioning, not human resources, right? So, so you essentially have the two tables in the same database, right? And then you can join them, right? Instead of having the tables across multiple databases. And that's the other thing. It has to be something you know in the query. So if you're querying for something, the key, the partition key, the sharding key, in our case was the URL ID. That's what we know, right? And that's based on that we know which database to hit. But what if I want to query on some other field that I have no knowledge in? So that is expensive because now you have no knowledge. You don't have the key. So you're forced to hit all the databases to know which key, right? Where this data reside, essentially, right? An example would be like, hey, if you have like customer West and customer East on two shards, right, and you searching by name, tough luck, right? Name has nothing to do with shard, so you have to query both shards. Summary, what do we discuss, guys? We discussed sharding. This is the meaning of sharding. Spread your tables into multiple database instances, right? We discussed consistent hashing, right? Just like a little bit, just consistently hash data into multiple entries, right? We discussed horizontal partitioning versus sharding, right? That's the difference between the little bit. We talked about the advantages, disadvantages with those. We went through code, guys. It was long code, right? And the code is available there, right? So we essentially wrote a URL shortener kind of a thing that shortens URL and expand those URLs, right? And then finally, we talked about pros and cons. Hope you enjoyed this video. I'm gonna see you on the next one, guys. You guys stay awesome. What is going on, guys? My name is Hussein, and in this video, I want to discuss a question that some of you asked me. When do I shard my database? And short answer for those of you who are impatient, last thing you want to do is the shard your database. There are so many other things that you can do before complicating your life with sharding. So with that said, let's just jump into it. Guys, sharding. The idea of sharding a database is, I know it sounds that the term sounds very sexy, right? So it's like, oh, I'm going to shard my database, and it makes you sound intelligent. But if you think about what you're doing with sharding, it is a very complex architecture and complex operation to implement. So in order to talk about sharding, you have so many other things you can optimize. It's like, why are you doing it to begin with, right? So let's start over. You have a beautiful database. And I'm now talking about mostly relational databases because that's my specialty. I very rarely work with NoSQL databases, but they work similarly. But here's the thing. In relational databases, you have a single instance database, right? And you're probably building a web application, so you need a web server or an API framework such as Node.js, Django, all that jazz, Go application, your custom application, that essentially speaks HTTP protocol that talks to the browsers or some REST clients or any gRPC, not really gRPC, but what is the thing? GraphQL, thank you. Yeah, so GraphQL, anything that's basically HTTP, and you make request, and that request goes to the web server, and the web server makes queries to the database and gets your back responses and kind of change the representation to something that the client understand. Could be JSON, XML, anything, and then ship it back to the client. That's the REST representational, right? Change the representation. All right, so that looks good. What's the problem with this? You get a lot of requests. A lot of people are reading, let's say. It's like, hey, I'm getting give me all this employees table, or give me, I'm reading this profile, I'm reading this for, I'm reading this tweet, I'm reading this thing. So you're hitting that database a lot. When you're reading a lot, you say, okay, that you're reading from a table, right? And that table is large. It's getting large because you're inserting a lot of stuff in it. It has 1 million, 2 million, 3 million, 4 million, 20, 40, 100 million rows in it. And you might say, Hussein, doesn't matter because I have an index on it, and that index is going to be smaller, right? And I'm going to hit the index because I'm smart. I am going to index the fields, and I'm only querying based on those fields that are indexed. So my queries are fast. But the index can get you only so far, because the larger the table gets, the larger the index gets, and almost you're doing a full index scan, which can also be slow. So the solution is not to just split everything into multiple servers. You're doing it, you're over-engineering too early, and that's what the problem with most people are, just over-engineering too early. You can still do so much stuff, right? Well, you have this is their problem now, right? You have to identify what the problem first in order to solve it. You cannot just solve something that you don't know what the problem is, right? Identify the problem. So let's say this is my problem. My reads are slow. I didn't say anything about writes is slow. It's just reads. Because writing is always fast. You're in writing to the end of the table, and even if you're using a B-tree data structure index, if you're using an SSD, that could be harmful for the SSD because you're rebalancing that tree sometimes if you're writing a lot, and that could cause some shifts in the disk, but still it's not that as bad as read, right? LSM is optimized for read, but writes, but that's another story. Writes. So I'm reading a lot. My read is getting slower and slower and slower. It used to take 1 milliseconds. Now it's like 20, and now it's 100 milliseconds. What do you do? Table's large. What do you do with it? There's something called, most databases supports, called partitioning. And I'm going to talk about just the horizontal partitioning. So imagine this is your table, and I talk about horizontal and vertical partition. I'm going to reference the video here. Go check it out. But in a nutshell, you have a huge table, hundreds of millions of rows. You just slice it in half. Horizontally. That's the horizontal. You slice it in the middle. And you say, this piece from this ID to this ID go to this table, right? And we're going to call this a partition. And this ID to this ID goes to this table. I'm going to go partition 2. And this ID to this ID go to partition 3. So now you, instead of having one table, you have 3 different tables that represent the whole logical table. But when you query, we can find out based on something called a partition key, which usually is the primary key of the table. Doesn't have to be though. But based on that, you can know which table to hit. Now you have smaller tables. You have 10 smaller tables. And guess what? With a little bit of knowledge from the client, we can know exactly which small table or partition to hit. And now I'm working with a smaller index, and my queries will be fast. Instead of having this huge index, now I have a smaller index, and I know exactly what to query. So my queries are fast, just like that, by just enabling partitioning. And most databases, Postgres, for example, does that blindly for you if you enable it, and the client doesn't have even need the knowledge to know that, oh, I need to hit this table partition underscore what. No, it's just happened for you. Previously, in older releases, you had to have this knowledge. Oh, this is this table, and this table, and this table. Remember, guys, I'm still in the same server. It's one instance, one database instance. But with a little bit of a tweak of a feature of my database, I fixed the problem. Right? You don't need sharding. We're going to talk about sharding in a minute, what does it really mean. But you come back. You say, Hussein, no, that's not good. Because yes, my singular reads are fast. I'm selecting star from this table, and yeah, it's very fast now because I partitioned and all that stuff. But my database server cannot handle, because all this TCP connection to a single server just to read stuff, it's overwhelming my server, and it's the file descriptors are blowing out of proportions, and I cannot handle it anymore, right? So what do you do? Well, I'm not even introducing the idea of caching. You can obviously introduce a layer of Redis cache and all that stuff, but it comes with its own problems, because you'll end up with inconsistency and you have to invalidate the cache and all that stuff. But you can play with that. And without introducing that extra layer, I have some tricks up my sleeve to fix that problem, right? And most of the stuff you guys know it probably, but replication, why is nobody talking about this? You have a master, backup. So, and some databases have this by default, this features where you have one master and create another server and make this server a backup of that master. And what it will do is periodically the master will push the edits, right, the writes to the replica or to the backup. So you can create as many backups as you want in multiple servers with partitions and do all that stuff. Now you segregated multiple servers, but you have one write. To do a write, you go to that dang server. You don't want to write in multiple servers. That will confuse a lot of things, and we're going to talk about it in a minute, because reading is easier than writing. Reading doesn't really cause conflicts. Writing, if I'm writing to the same row, yeah, in different servers, bad things happen. How do I reconcile these changes, right? It's just, you can solve it, but it becomes a very challenging problem to solve. So you want to avoid complex problems. And how do you do it? Okay, well, I'm going to write to my server because my writes are not as bad. I often barely write anything, but I read a lot. So you can just multiple servers. You have one master server and just push all that stuff to the replicas or the backups. And now your clients or the web servers put a reverse proxy, HA proxy, Nginx, H, anything you want, and then start funneling. Oh, you want to read? Go to this database. Oh, you know what? Read? You go to this backup. Go to this backup. And now you're balancing the reads. But the writes still goes to this database. That is the master. And some people will come say, oh, no, Hussein, you don't know me because I write a lot and I need to write a lot, and my single server that does the write no longer is sufficient. It's gonna die because I write so much to it. I really doubt it first, because if you're writing a lot, you must be writing a lot to saturate a single server. I'm assuming you have a big server that does that stuff, right? But let's say you do. You're writing a lot. You still have some tricks before the final thing, which is sharding. You can do multiple replication, a two-way replication, but have two masters on different regions. In the US, this is very common. This is a US East and this is a US West. People from Florida writes to this server. Anything that has to do customers with the East, just deal with this. Anything that has to do with customer of the West, deal with this. And most of the time they don't overlap, right? Rarely. So if you have this segregation, use it to your advantage. And then synchronization of this can happen very easily because you're barely going to have any conflict. And if you do, you're going to resolve it. And if this is too complex, you finally go and do sharding, which is the following. Sharding is the idea of having a single key. See, after all of these are exhausted, right? Come down and do sharding, right? If all of this stuff are exhausted, then go do sharding. If none of them, then probably you don't have to do sharding, because sharding is the most complicating thing to accomplish. And let's talk about what. It's become easier these days, but let's talk about sharding. So, what is sharding? Sharding is the idea of splitting, like partition, like horizontal partitioning, but put the tables that are partitioned not in a different table in the same instance, same server. No, put those partitions or shards in a different server altogether. Whoa, okay. Yeah. With partitioning, you can still do transaction, by the way, guys. The database supports transactions. With sharding, with sharding, my tongue has been swallowed. With sharding, you cannot do transactions. Forget about transactions. Bye-bye, rollback, all this beautiful commit stuff, acid, atomicity. Bye-bye. No sharding for you. You cannot do all that stuff. Because what do if you want to write to multiple shards? This is different servers, right? And you cannot maintain the ACID transactions. I know some people don't like ACID transaction and favor the others with the eventual consistency, but I'm the oldest school kind of a guy. All right, so what you do is, I am about to update customer number 100. And customer number 100, you say, okay, the client, you're the client, which is your web server in this case. So, okay, customer number 100 is between 1 and 10,000. So yeah, it's server number 1. Let me establish a TCP connection with server number 1 and execute the write or the read, right? And you received another request, but this request has to do with customer number 10,017. Oh, 10,017 is between 10,000 and 20,000. And based on my sharding range, this is server 2. Establish a TCP connection to the server 2 and execute it and come back the result. And yep. You might say, yeah, I'm going to use pooling because I don't want to establish a TCP connection every time I enter. And I absolutely agree with you. You have to use pooling. You don't have to do this cold start of TCPs. Hopefully one database platform we're going to use quick and all these problems will go away. The cold start and all that stuff. But yeah, sharding is very complex. That logic that we just talked about is in your client application. That's hard, right? It's very, very hard. By the way, I made a video about sharding, guys, and actually show you how it's done. Check it out here. But what do you do, guys? Right? This is do you really want to do this with your life and sacrifice rollbacks and commits and transactions and all this stuff just to do a stinking sharding? Just to do what? Scaling? You just want to scale the writes? I agree. It's beneficial. But sometimes it's an overkill. You gotta really need to think. Do you really need to shard? Right? Alright. That being said, YouTube ran into this problem. As you might think. Because YouTube is a millions of videos which with billions of watch hours and hours uploaded, right? So thousands and thousands of hours are uploaded to this platform and comments and I watched listened to a podcast with the lead of YouTube talking about how they solved it. They have a MySQL database on the back end, by the way. They manage all that stuff, and the videos are, I believe, I forgot where it is, maybe S3, I might be wrong there. That was before Google acquired it and all that stuff, right? So they moved everything to YouTube, to Google infrastructure and all that stuff. But for a long time, they had a single MySQL server and they managed to do fine until the writes became absolutely disastrous. So they started doing what we talked about, and until they couldn't handle, so they had to do sharding, which is called, what we talked about is application level sharding. The application is aware of the shard, which is this piece of the partition. Okay. And when you're aware, that's a problem, because you create coupling. And coupling is the worst thing you want in software, because you want software to be as isolated as possible. You want software to have social anxiety, social distancing in these days. True social distancing for software, right? Keep your software apart. They shouldn't know stuff about each other. That's just a general idea about software. Coupling is bad about software. Come back. Now, what they did is like they had this application level sharding for a long time. And it's like, okay, this is ridiculous. We cannot maintain this, because if they want to change some logic, everything breaks, right? They want to forget about resharding. The idea of resharding is like, oh, okay, I want to change the range from 10,000 because 10,000 is really low. Let's make it 100,000, right? Each shard has 100,000 rows. Oh, forget about that. Nobody can do that, because that will break every single client. You got to go to that client, and yeah, so it's complicated. So they created this technology called Vitess, and I'm going to reference it here. Vitess is essentially a middleware that you send your query on top of MySQL, and I believe it's open source, right? And it's Kubernetes ready and all that jazz. And you put it on your MySQL architecture, and it's going to do the magic sharding for you. And that is awesome, because you send a beautiful SQL query, and they parse that query and they understand what shard to hit. And you don't need anything better than that, if you absolutely need it, because nothing's for free. If you have the maintenance cost of implementing Vitess, go ahead and do it. Any technology you implement, there's a cost for it. If you're ready, go ahead, but ask yourself, do you really need it? Sometimes you do not need it. That was an awful British accent impression. All right, guys, that's it for me today. We're all learning. We're gonna learn a lot and keep learning, guys. All right, guys, I'll see you in the next one. Goodbye.